welcome everybody. It is chapter 11, lesson 2. You have me and Michaela here for triangles. All right, remember that this is a video lesson, so I'm going to put you'll have the Pear Deck link here, and this video should be embedded. This is for the homework that supports it, so we're doing a lesson 11.2, and your homework page is 647. Problems 1 through 6 will be done here, and number 8, and then 648 all. So I'll be doing them. So remember, as you see the problems, stop the video, work them out, and then see the answers. So by the time we've been classifying polygons, which are two-dimensional shapes that are closed, have more than two sides. They have angles and vertices and sides. So we're going to look at a specific polygon, a triangle. And just like we classified the regular and non-regular polygons into categories, we are going to classify triangles into isosceles, scalene, or equilateral. And you notice this one has the word equa in it. So I'm wondering how it will be equal. We're going to be analyzing the angles to explain if a triangle is an acute, obtuse, or right angle. And these are lessons that you should be bringing with you from 4th grade. So how can you identify and classify triangles? So remember, we have our polyhedrons, the solid figure that all the faces are polygons. These are the different polygons. We're going to be studying the triangles and the rectangles and the squares. And then if you actually attach them so they create a solid figure, that's a polyhedron. Prism is a solid figure again that has two congruent or equal polygon-shaped bases, and the other faces are all rectangular. So there's a rectangular prism. A pyramid is another solid figure. The base is a square, and then on all four sides of the squares, a triangle comes up and meets at the vertice. Quadrilateral has the word quad for four. Polygon with four sides right there, and four angles. But look, they don't all have to be the equal length or equal distance from the vertices together. You have different lengths for each side, and they can have equal measurement of angles, but they can also have different measurement of angles. So a quadrilateral isn't always a square or a rectangle, but a square and a rectangle are always a quadrilateral. Then you have a regular polygon, and this comes in this word congruent, which we learned means equal, right? So are all the sides equal in length and all the angles are equal in measurement? That makes it a regular polygon. That doesn't mean it has to be a square. It can be many different shapes. A scalene triangle is an angle with nothing that's congruent or equal. So all the sides are different lengths. A unit cube is a cube that has a length, width, and height of 1 unit. All right, so that is just a general unit of measurement. And we can change that 1 unit to be 1 meter all the way across, or 1 inch, or 1 centimeter. Volume is the measure of space that a solid figure occupies. So capacity is what goes into it, and volume is what space that object actually encompasses. All right, so let's look at our first problem. So look at the Epcot Spaceship Earth building in Orlando, Florida. You may see a pattern of triangles. The triangles outlined at the right have 3 congruent sides. That means you see that 3 equal sides and 3 acute angles. What type of triangle is outlined? So complete the sentence. So we're going to be classifying triangles by the length of their sides, and we're also with the angles inside. So let's take a look at how that works. All right, so here's an equilateral triangle. It has, you can see they actually put measurements on it. So it has 3 sides, and each side is the same. They're equal. Each one is 3 inches, so it has 3 congruent sides. But if you look, remember I was telling you yesterday about this design for the angles, it's using the same arc, just one arc. So each of these angles are also equal or congruent. So an equilateral triangle has that word equal. The sides are equal and the angles are equal. An isosceles triangle, where these are all the words for sides, the isosceles triangle has how many sides that are equal or congruent? You can see it right here, 2, 1 dash on each, and they're each 3 inches, but this last side is a different length. So an isosceles triangle has 2 equal sides. All right, so an equilateral, everything's equal or congruent on the sides, and isosceles only 2. So then what would a scalene be? Well, if you have 3 equal sides for equilateral, 2 for an isosceles, well then you'd have no equal sides for a scalene. All right, so scalene stops it all and has no equal sides. All right, so that would be 0. So then we also have measurements. So a right triangle will have that right angle, and you can see it right here. Okay, that's where these are perpendicular. And a acute triangle has 3 angles, angles. 2 of them are the same measurement, 75 and 75. And then obtuse has 1 angle that is bigger than 90 degrees. So this big long angle right here. So an acute means all of them are kind of cute. They're all less than 90. All right. Is an equilateral triangle also a regular polygon? Yes, because all the sides and all the angles are equal. All right. So the type of triangle outlined in a pattern can be classified by the length of its size as a what kind of triangle? So go ahead and give these a go. So the pattern I think it's talking about is this one right here. So what pattern would that be? Are all the sides the same length? Are all the angles the same length? If so, that would be an equilateral triangle. Does it have one angle that's just really large, more than 90 degrees, or any sides that are different? That would be one of the other two. So in this case, I'm going to say it's an equilateral triangle. It can also be classified by the measure of its angles as a what? So this triangle right here is an equilateral triangle, but it can also be classified, this one right here, as an acute because they're all smaller than 90. So when I look at this one, I know there are no right angles. So this is an acute triangle that is also equilateral. All right, classify each triangle, write isosceles, scalene, or equilateral, and then write acute, obtuse, or right. So go ahead and pause the video and give that a go. All right, how did you do? I noticed this little square represents right angle. So this would be a right triangle. And I noticed that all 3 sides have different lengths, which means that it is not equilateral. It's not equal. It's not an isosceles. That's 2, so it would have to be a scalene. Right, none of the size measures are equal, and I could tell by the different measurements. And I know that this is 90 degrees, this is 53, and that's 37 degrees. So none of the angles are equal either. Okay, but this one square represents the right angle. All right, so for this one, I can tell by the dashes that these 2 sides are the same length, but this bottom one is 42 inches. And I can tell that this is a really large angle. It's more than 90 degrees, so it's called obtuse, which makes this an obtuse triangle as well. All right, so give this one a go. You want to label this. A triangle with sides has the length and angles measured given. Classify them. Write scalene, isosceles, or equilateral. And remember, that has to do with the length of the sides. Then write acute, obtuse, or right, and that has to do with the angles that are inside of it. All right, so here's the measurements just to make sure it's really clear rather than trying to figure it out. So go ahead and stop the video, write out what you think it is, and you can go back and check. All right, so you had 4 problems, 3, 4, 5, and 6. Just looking quickly, these 2 sides were the same length. These 2 are 50, that's 15. So this is a what triangle? An isosceles. An isosceles has 2 lengths of the triangle that are the same length, same distance. And then all of the angles are really cute. They're all less than 90 degrees. I could just tell by looking at them. So it's a very cute angle, which means it's an acute angle. Here I have this box, which represents right angle. So right away I know this is a right triangle. And again, I have 25, 24, and 7, which are all different lengths. So it is a scalene triangle. Here they just gave us the measurements. My sides are 44 millimeters, 28 millimeters, 24. None of them are the same, which makes it scalene immediately. My angles, though, I have a tiny little cute 30, a tiny little cute 40, and then this really large, more than 90 degrees obtuse angle. So this would be an obtuse triangle if I drew it out. This one, again, my sides are all different lengths, 23, 22, and 13 millimeters. So that's, again, scalene. And then my angles are all pretty cute. They're all less than 90, 62, 72, and 46. So this is an acute triangle. All right, let's take a look at the next problem. All right, we're getting into word problems. So stop the video, give it a go. All right, so I took these problems and I wrote them down on my paper, and we're going to take a look at how I solved them and see if you solved them as well this way. All right, so for question number 7, the question was, can you have a pen for a horse that is an acute right triangle? So remember, right triangle has to have this square. The square represents 90 degrees. Well, you may not know this,